Hello friends, welcome to Tolerance Stack Up Lecture 3. In this lecture, we will quickly revise terminologies like virtual condition, resultant condition, and we will practice loop diagram. I hope before watching this video, you have watched Stack Up Lecture 1 and 2. It will help you to grasp this easily. Let us quickly revise virtual condition and resultant condition. Virtual condition is worst scenario, whether it is shaft or block, hole or slot. Resultant condition is best scenario for both. So virtual condition for shaft is block MMC or shaft MMC plus GTOL, and resultant condition is its LMC minus GTOL minus bonus. For hole or slot, virtual condition is its MMC minus GTOL, and the resultant condition is its LMC plus GTOL plus bonus. Now calculate equivalent dimensions. It will be virtual condition plus resultant condition divided by 2. Same as equivalent tolerance will be virtual condition minus resultant condition divided by 2, or resultant condition minus virtual condition divided by 2. Depends on hole or shaft. This dimension will be used in our stack up analysis. Before going ahead, let's quickly revise the rules in preparing loop diagram. So first rule is the loop should be closed one. To find a gap, the loop should be closed one. Second rule is to move from one component to other component, there should be some surface to surface contact or both components axis is aligned. Okay, so move from one component to other component, there should be some surface contact or their axis must be aligned. Third rule is loop diagram should be in one direction only. If you are preparing loop diagram for linear components or for anything, if it is horizontal, it should be horizontal. If it is vertical, it should be vertical one. Or if it is if angular dimension involves and you are doing polar kind of loop diagram, so it should be in only that direction only. So loop should be in one direction only. We will practice it more. Let's first prepare the loop diagram for the example I have given in lecture 2 for your practice. First, convert all the dimension into equal bilateral or symmetric tolerance system. See lecture 1 or 2 for more details. Let's prepare loop diagram for this example. So in this example, we are interested in find out this gap and this gap. So to find out this gap, from we can start from this surface or this surface, right? So let's start from here. So I will start from here to here, and now I am over here as we have this block length. So we can move from here to here. Now I am at the bottom of component 2, which is resting on the component 1. So there is surface to surface contact. According to rule number 2, I can jump from component 2 to component 1. Now I am on the surface of component 2. So I can start from here and go to here because I have the dimension of the slot. So I can go from here to here. I will name the loop A and loop B. So this is how we have started from here and we reached over here. So loop is closed one. So we have satisfied the rule and we are doing it vertically. No other dimension is involved over here. So this is the loop diagram for this gap. You can now go ahead and prepare the stack up table and find out the gap. Same way we can do same thing for this gap. Now I can start from here or here. Let's start from component 2. So I will go from here to here, right? Loop A. I'm doing it horizontally, so there will be only one direction involved in this stack up. So I will go from here to here as the surface of the component 2 is in contact with the surface of component over here. So I am reached on the surface of component 1 also. So I can move from here to here as 3 dimension, 3 plus or minus 0 is given on this thickness. So now I am on this surface. I can go from here to here. So this is, I will name it B and C. So this is how loop diagram prepared and how dimensioning affects our loop diagram. Because in this case, I have just given the dimension of this slot and the height of this block. So I can directly move from here to here. So there is only 2 dimensions involved in that gap. But in this case, there are 3 involvement of dimensions. So A, B and C. So this is going to be more critical. If you are in your stack up, if there are number of dimensions involved, that means the tolerances are going to be add more and more, and it will create problem in assembly.
Let us do the stack up for diametrical component. Mark dimension will be considered to the gap analysis.
How we can do gap analysis in this case? We can do it radially. So we are assuming that axes are aligned. So we can find out this gap. What would be the maximum or minimum gap over there? So I can start from the shaft outer surface to its axis. So that is A in the loop. And then assuming that center of the holes is also aligned, I am on the axis of the hole also. So I can go from here to here, B dimension. So I can find out the gap. I have did the loop diagram in this. Now let's prepare stack up table for this. I will take downward direction as -1 and upward direction as +1 and tolerance over here. So A dimension is downward and I will take it as a negative dimension. What would be that? 5 divided by 2, because I have did it radially. Same way I need to divide its tolerance also. So it will be 0.1 divided by 2. Now what is B? B is in upward direction and it is positive dimension. So I will take it 5.1 divided by 2 and its tolerance 0.05 divided by 2 over here. Because I am doing it radially, so I need to divide the tolerances also. That's why I took this example. So in that our table is prepared. But one question is over here, why downward is negative and why upward is positive? There is no such rules in loop diagram to decide how I can take a direction negative and how can I take a direction positive. But one thing you can do, the dimension which is going to be smaller and will add up to the gap, means when this diameter will be smaller, the gap will be more. So I need to keep this as a negative side, and when this whole size would be bigger, the whole side would be bigger, then it will add to the gap. So if it when it is going to be bigger, it will add to the gap, so I will keep it as a positive. So any dimension going to be bigger and will add to the gap, it will be positive, and any dimension to be smaller and it will add to the gap, then it will be negative. That's how you can prepare which direction will be negative and which direction will be positive. So in this we have prepared the stack up table, and now you can find out the gap by doing this analysis. So this would be minus 2.5, this would be plus 2.55, and it would be 0.05 plus 0.025, that would be 0.075. Now to find out minimum and maximum gap between these two, we will add these two, that is minus 2.5 plus 2.55, that would be 0.05. So 0.05 plus or minus 0.07 is the gap we are going to get.
This is the second example. In this, component 1 has two tapped holes on both end faces. Component 2 has two holes. With the top hole, it will be assembled with the component 1 at both sides. Now a rod is assembled from the bottom holes.
In this case of assembly, component 1 has two tapped holes and component 2 is coming from both sides and it is going to be assembled by a bolt over there. So both component will be assembled easily because I can move my component 2 up and down and can locate with this hole. There will be no problem because there is the single hole on these both plates on both sides. So I can up and down this plate and over here also, and I can easily assemble. But after assembling it, there is a hole on this plate both sides, so I need to insert a shaft or a bar from there. So it can create a problem. Suppose due to all the manufacturing of component 2, this hole gets shifted upper side and this hole gets shifted downside. Even these whole sides should be such bigger than that it can accommodate the shaft in the worst case of mismatch. What it could be, if you can see this image from here, so hole is over here and the shaft is coming on upper side of it, and if we see here, the hole is here and shaft is coming downside of it. So with this mismatch, if our holes are going to accommodate the shaft, the assembly will be correct, otherwise there will be foul play. So how can we do stack up analysis for that? For this, we can do find out the axis mismatch between these both holes, and then we can decide what the clearance diameter is required for this diameter of shaft. So how we can prepare the loop diagram in this case? Suppose I need to find out maximum mismatch over here and I'm on the axis of this hole. So I can go from here to top surface of the plate because I have given the dimension from there. So that is A. Then I have located the hole from this haze again. So I can directly come to that hole. Now as there is a bolting, when there is a bolting between two plates or two holes, the whole axis must be aligned and it can be assumed same. So here I'm on the axis of this hole, so I will be on the axis of this hole also because it is a threaded and we are going to going to bolt from here. So we will assume the axis is same. Now I am on the axis of this component. I can easily go from here to here on the surface of component 1. So A, this will be B, then C. So I am on the surface of component 1 on this surface and I can come to the axis of the tapped hole. So again coming down, so it will be D. Now both axes are same as there will be bolting. So I am on the component of 2 hole axis. So I have to go to the surface also because I have located this hole from the end edge. So I need to go up again. That will be E dimension. Then I am on this surface. I can come to the center of this hole on this plate. So I can come down over here. That is F dimension. Now we will go ahead to prepare the stack up table. But there is a one question. Which direction we are going to take as a plus and which direction we are going to take as a minus. So in other cases we discuss the dimension which is going to be smaller and will add to the gap will be negative, and the dimension which is going to be bigger and is going to add to the gap will be positive one. But in this case, any direction you take plus or any direction you take minus, it doesn't matter because we are checking the axis mismatch, not the gap. So in these cases, up direction you can take plus and down direction you can take minus. So we will go ahead with that.
Highlighted dimensions are named as per loop diagram.
Now we have prepared the stack up table. But before going ahead to prepare stack up table, we need to convert all the unilateral or other system of tolerances to equal bilateral tolerance of the system. Even any kind of geometric tolerance is applied on that, we need to convert its equivalent tolerancing system. In our case, as we are calculating the axis mismatch, the direction doesn't matters, as we have prepared the table and you can see the value, both are coming same, one is positive and one is negative, and the tolerance is over there of 0.48. So 7.75 minus 7.75 is 0 plus or minus 0.48. So axis mismatch is going to be around 48.48. So our clearance hole should be bigger 0.48 into 2 of the diameter of shaft. Suppose the diameter of shaft is 6 mm. So the diameter of hole should be 6.96. So or more than that. So if our hole in that component is of diameter 6.96 or more, it will easily accommodate the diameter of 6. Otherwise, there will be problem in assembly. These were some example for preparing loop diagram and doing tolerance stack up analysis. Please practice it by yourself. There will be queries. Please comment on my video. I will reply back. And there will be one more lecture coming with some more complicated example. Thank you.